Okay, so what we're going to learn how to do right now is volume of a solid by revolution about an axis. So there's two different methods that we're going to talk about in this video. The first one's going to be Washer's method. Sorry, I'm trying to figure out the video. Okay, so when we do Washer's method, the formula, and it's pretty much the same formula for both washers and discs. So Washer's method or disk method is V is equal to the integral of A dx. And when we're dealing with a washer or a disc, it's in the shape of a circle. So our cross sections are going to be circles. So the area of a circle is pi r squared. We're going to go from A to B. And I will show you how to do all this stuff as we go throughout the lesson. So we're going to start out with discs method. First, it's no different from Washer's method. Okay, so first example, find the volume of the solid created by revolving y equals square root of 9 minus x squared about the x-axis. Okay, so our steps are pretty much going to be the same as the last lesson when we did area between curves. So your first step is to graph it. Now, if you didn't know what this graph looks like, it's the equation of a semicircle, okay, that has a radius of 3. So it's going to look something like this. And this is one of those basic graphs you should know what it looks like. Okay, if it had the negative portion, it would make a full circle. Okay, so your first step is graph. Your second step, your limits, or your intersection points. So we're looking at our limits for this region, and it's going to go from -3 to 3. Now, from there, and we're always going to do this, is we're going to draw a little ladder that is always perpendicular to the axis of rotation. So our x-axis is our axis of rotation, so we draw your ladder up to the region. Now, my region is all colored in. It's all this area right here. Now you're going to hear me talk about, is there any sort of white space in between the region and the ladder? And the answer is no, because the ladder goes straight up to the region. Now when we start doing Washer's method, it'll be a little bit different. So just make sure you make those comparisons. Now, the ladder is used for, it's called a representative cross-section. The ladder can be drawn anywhere, okay? Now, we're going to still use the same concept of top curve minus bottom curve. So when we go to do the volume, it's pi times the integral from -3 to 3 of your top curve minus bottom curve is going to be your r. Okay, so my top curve is square root of 9 minus x squared, right? And my bottom curve in this case is going to be 0. So it's 9 minus x squared minus 0. So this is your top curve minus your bottom curve. Okay, so square root of 9 minus x squared minus 0 is just square root of 9 minus x squared. And we're going to plug into the formula. Square root squared gets rid of the square root. And this one's easy enough to integrate by hand. So we'll do it. So we get 9x minus 1/3 x cubed. And we're going to go from negative 3 to 3. Plug in our top limit, 9 times 3, minus 1/3 times 3 cubed, minus 9 times a negative 3, minus 1/3 times a negative 3 cubed. Okay, 9 times 3 is 27. 3 cubed is 27, divided by 3 is 9. Okay, 9 times negative 3 is a negative 27. And this is going to be plus 9. Okay, so our answer should come out to be 36 pi. Don't forget about the pi on the outside of the integral. Okay, so we can write that in there if we want to. Okay, now, most of the time on these types of questions, they're going to be, if you have to integrate it fully, it's going to look like this. It'll be something really easy to integrate. If you're on free response, a lot of times they're just going to be setup questions. So they would want to see this answer right here. Okay? Let's look at another example, and then we'll move on to Washer's method. Okay, so let's find the volume of the solid. Formed by revolving f of x is equal to square root of sine of x from 0 to pi. Okay, now I don't know what this graph looks like. So I would say that this is acceptable to probably put in your calculator. So if we do graph this in our calculator, it's going to look like this, from 0 to pi. Something like that. Now, when you graph trig, make sure you're in radians. Okay, our limits. Well, our limits are given to us by the 0 and the pi. And now we're going to find our r. Now we find our r by doing our little ladder. Our ladder is drawn from the axis of rotation. And we're going to, I left this out in the example problem, from about x-axis, sorry. So our r is found by doing top curve minus bottom curve, okay? So our top curve is square root of sine of x, and our bottom curve is going to be the x-axis, which is y is equal to 0. So it's square root of sine of x minus 0. Okay? So we're going to integrate this from 0 to pi, and it's going to be square root of sine of x squared dx. So we're just following the formula, pi r squared. So we take this and we're going to plug it in right there. So remember, whenever we square something, the square root goes away. Okay, and then the integral of sine of x should be negative cosine. Okay, and we're going to leave the pi on the outside. Cosine of pi is a -1. Negative times a negative is a positive. Cosine of 0 is 1, so it's a -1. So my answer should come out to be 2 pi. Okay. Now I am going to attach some sort of applet or video that will let you see what solids of revolution actually look like three-dimensionally. And it'll give you a better idea of what you're actually doing for you visual people. Okay, now we're gonna get into washers now. And these are going to be a lot of set up questions. So we'll go through quite a few examples with this. This is always pretty much guaranteed to be on the free response questions. So as we work through our classwork this week, you're going to have more and more free response questions. Okay, so find the volume of the solid. Formed by revolving y is equal to the square root of x, and y is equal to x squared about the x-axis. So, your first step is to graph, just like we did before. Y equals square root of x, something like that. And then y equals x squared looks something like that. Okay, your graph does not have to be perfect. It's just some sort of idea to what you can get the top curve and the bottom curve. Now, we're not given the limits like in the previous two problems, so we have to find the intersection points like we did in the last lesson. So your intersection points, square root of x is equal to x squared. And then to solve that, we're going to square both sides. So we x to the fourth is equal to x. And we're going to bring everything over to one side, factor out the x. And we're going to set everything equal to 0. So x is equal to 0. And x is equal to 1 should be my limits. And that's what that visually looks like. You have limits of 0 and 1. Okay. So my next step is to draw my ladder perpendicular to the axis of rotation. So my axis of rotation is going to be the x-axis. Now, this is what I was talking about earlier. We're going to have some sort of white space in between the region and the axis of rotation right here. Okay? So visually, like a washer. A washer is pretty much a circle that has a hole in it. So if you can envision a donut. So we have to subtract that region out. So we're going to do something called R big and R little. R big extends the whole length of the ladder. So you do top curve minus bottom curve. Okay? So it's square root of x minus 0. And if I do R little, it's top curve minus bottom curve. We subtract out the white space. Okay? So it's going to be x squared minus 0. Like that. This is going to be a little bit tricky at first, but that's why we're going to do a whole bunch of setup examples from there. So when we go to do our volume, it's going to be pi times the integral from 0 to 1 of r big minus r little squared. Okay, so it's going to be square root of x minus 0, which is square root of x, right? And this just is x squared. And then we're going to subtract out the white region with my r little. Like that. Okay. Now, we're going to evaluate this. We're going to square the square root, which we just get x. And x squared squared gives you x to the fourth. Now, when we go through and integrate this, we're going to get 1/2 x squared from 0 to 1. And then this is going to be x to the fifth, 1/5 from 0 to 1. So we'll end up getting pi times 1/2 minus 1/5 Getting a common denominator. Common denominator is going to be 10. So this one's missing a 5. So it should come out to be 3 pi over 10. Okay? So we are going to use this same region for another example problem. Okay? And we are going to, we're just going to set it up. We're not going to work the integration or anything like that. So same region. So same picture as this one. But we are going to rotate it about the y-axis now. Okay? So this is y is equal to the square root of x. This is y is equal to x squared. And this was the point 1, 1. Okay. And this is the point 0, 0. Now, we're going to rotate about the y-axis. Okay. So we'll rotate this about the y-axis. We have our intersection points. We have our graph. We're going to draw our ladder perpendicular to the axis of rotation, like that. Now, when we go about the y-axis, it has to be x equals in our equation. So this is x is equal to square root of x, square root of y, sorry. And this is going to be x is equal to y squared. Now, yesterday, or in the last video when we did area between curves, we did right curve minus left curve. So we're going to use that same concept. Your R big is going to be your right curve minus left curve, and it extends the whole length of the ladder. So it's going to be y squared minus 0. And then I have to subtract out the white portion right here. So I did that wrong. Sorry, I did that wrong. I was looking at the wrong graph. Okay, so your right curve is this one right here, so it's square root of y minus 0. We do r little. We're subtracting out this portion right here. So it's this graph right here, so it's going to be y squared minus 0. And from there, we're just going to set up the integrals. We're not going to do anything special or fancy with this. We're not going to try and get an answer. So your volume is going to be pi times the integral from our y values are going to be 0 and 1. And it's going to be square root of y squared dy minus pi times integral 0 to 1 of r little squared, which is going to be y squared dy. Now, just as a recap, so if it says go about a vertical axis, which y is equal to the y-axis is a vertical axis. It's the line x is equal to 0. You have to do right curve minus left curve. So your r big is going to be this curve minus 0, okay? And then you have to subtract out the white space. So it's going to be this curve minus 0. And when we go to find the volume, it's going to be r big squared minus r little squared. Okay, so let's take an example, and we're just going to set up a whole bunch of different things with it. Okay, so we're going to set up, but do not evaluate. Okay, so a lot of times they're going to look like this. So we have the region y is equal to 9 minus x squared, x is equal to 0, and y is equal to 0. So we're going to graph that region right there. So we're going to need to draw a graph every single time we do these. Okay? So 9, somewhere up there. So it should cross at 3 and -3. Now, it says we're going to rotate the region 9 minus x squared. X is equal to 0, is this line right here, the y-axis, and y equals 0. So we're just looking at this region, this portion right here. So our limits are going to be 0 and 3, this point. And then up here, it'll be the point 0.9. This point's going to be 3 and 0. Depending on which axis we're going about. Okay, so first little portion, let's see. Let's rotate about, let's go about x-axis. Okay, so if I rotate it about the x-axis, I draw my ladder, perpendicular to the axis of rotation. Okay, there's no white space in between the ladder and the region and the axis of rotation. So we don't have to do Washer's method. We don't have to subtract out. We don't have to do R big or R little. So our volume is going to be pi times the integral from 0 to 3 of top curve minus bottom curve. Okay. So it looks like that. Your R in this case would be 9 minus x squared, and your bottom curve would be 0, so that's all we plug into the formula. Now, let's rotate about the line y is equal to a -2. Okay, so I'm going to redraw my region, just a little sketch out to the side. Okay, so this is my region. And the line y is equal to -2 is down here. So I'm going to draw a little dashed line. Now, our next step was to draw the ladder perpendicular to the axis of rotation. So our axis of rotation down here looks like that. So there's going to be white space in between the ladder and the region. So we're going to have to do an R big and an R little. So R big is going to be top curve minus bottom curve. So it's going to be 9 minus x squared minus a -2. Top curve minus bottom curve. Now your R little is going to be top curve minus bottom curve. So it's going to be 0 minus a -2. Okay, and simplifying, that's what your two R's come out to be. Now, we're going to plug into our formula for volume. It's going to go from 0 to 3 of R big squared minus R little squared. And that's our answer right there. Now, let's take the same region and let's go about y is equal to 15. Okay, so if I was to draw my region, oh, sorry, I drew it wrong. So this is our region, same region. Now, the line y is equal to 15 is all the way up here. So we're going to draw our ladder perpendicular to the axis of rotation. Looks like that. Now, there's white space in between the axis of rotation and the region. So we're going to have to do an R big and an R little. Your R big is going to be your top curve minus bottom curve, and it extends the whole length of the ladder. Okay, so 15 minus 0 is 15. R little is going to be 15 minus 9 minus x squared. Okay, and simplifying this out, you get 15 minus 9 plus x squared, so it should be x squared plus 6. Now, you don't necessarily have to simplify that. On free response, you could have left it like that and just make sure you plug into the formula correctly. So volume is equal to pi times the integral from 0 to 3 of r big squared minus r little squared. And that's it. Now, let's do one more example with this, and then that will be the end of this video. Okay, so let's go and let's rotate about the line x is equal to a -2. Okay, so first step is to draw a region. And then our axis of rotation. So x is equal to -2 is over here. So in the previous examples, we're going about a horizontal axis. See, this is a horizontal line going in this direction right here. We're going about a vertical axis in this example. So what we're going to do is you have to solve for x equals. So we had y is equal to 9 minus x squared. So anytime we have a vertical axis, you have to solve for x equals. So this is y minus 9 is equal to -x squared. And we are going to divide both sides by the -1. So x is equal to plus or minus the square root of 9 minus y. Now, we are going to be in the positive region because it's we're in quadrant 1. So we're going to use the positive branch. Now, we have to find our R big and our R little. So we're going to draw our ladder perpendicular to the axis of rotation. And when it's x equals, we have to do right curve minus left curve. So R big is going to be right curve minus left curve. So it's going to be square root 9 minus y minus a -2. The negative turns into a plus plus. Okay? R little is going to be right curve minus left curve. We subtract out the white portion of our ladder. So it's going to be 0 minus a -2, which is equal to 2. Now, when we go do our volume, we have to use y limits. So we're going to go from 0 to 9, 0 to 9 of r big squared. And we're putting dy because we're in terms of y, minus pi times the integral from 0 to 9 of 2 squared dy. And that's our setup for this example. Some of you already know how to use shells on this. I really don't think we need to do shells because it doesn't come up that much as far as on the AP exam, but it's useful in some cases, especially so you don't have to solve for x equals every time. Okay, So hopefully this helps out, and we're going to keep working on this for the next week. The next section we're going to do is cross sections with different shapes to build a solid. So hopefully this helps, and if you have any questions, get back with me. Thank you.